All right, let's talk about the Agentic Lifecycle. It's a whole new way to build reliable AI systems.
For so long, software was all about certainty, right? Well, with AI, that's changed. Now it's all approximation.
So how do we actually engineer this stuff? How do we move from just alchemy to real architecture?
Look, traditional code is binary. It's a pass or a fail. Agentic systems need something new, semantic evaluation.
So forget simple pass-fail. We need graded rubrics that can evaluate an agent's reasoning. The why really matters now.
So what are we testing for? It's really three things: the results, the path it took, and its safety.
Your agent isn't a calculator. Think of it like a junior dev, so you have to review its entire process.
For real reliability, you must version the model, prompt, and tools together. They're a single, immutable unit.
This all gets managed by an automated pipeline. Think of it as a gatekeeper, testing against a golden data set.
And before going live, we use shatter deployments to diff the new agent's reasoning against the one in production.
Okay, so it's deployed. Now the real challenges start: observability, orchestration, and of course, security.
Simple logs just won't cut it anymore. We need traces that show the agent's entire chain of thought.
This creates a feedback loop. Every single production failure automatically becomes a new test case. That's how we get self-healing.
For the really tough jobs, you build a team of agents. The two main patterns here are supervisor and swarm.
The supervisor pattern gives you tight, centralized control. Swarm, on the other hand, is all about decentralized autonomy.
But all this autonomy opens up a huge vulnerability: prompt injection. It's how attackers can literally hijack your agent.
It could be a direct command from a user, or something subtle, hidden inside a document the agent is reading.
So how do you defend against this? The best way is a dual LLM guardrail. One LLM just scans everything.
That guardrail is just one piece of a full zero-trust architecture, complete with sandboxed, air-gapped execution environments.
This means our role as architects is changing. We're now the bridge between reasoning, engineering, and our legacy systems.
We've boiled all this down into 10 core engineering principles. You could think of it as a cheat sheet.
Because here's the bottom line: autonomy without architecture is just anarchy. This is the engineering challenge of our time.